Welcome to EDU World Space.
Okay, so this problem involves taking a charge and moving it from one position to the other, and it asks what's the work done on one charge by the other. And let me try to make that line straighter. So you have Q1 at the origin, Q2 starts out at this original distance of 0.15 on the x-axis, which I'll label now. So that's your Q2, and then it goes basically like up here to the coordinate 0.25 comma 0.25, oops, not 2m, 0.25 meters. These are all meters. And to get the work done on the charge by the other charge, you want to invoke the idea that work is minus the work done by an internal force. In this case, the charges are the internal objects, so they're the ones doing producing internal forces on each other. That's the negative change in potential energy. So that's minus the change of U final minus U initial. The potential energy between two charges in general is K Q1 Q2 over R, where R is the distance between them. And so in the original position, the distance is just 0.15, but after it moves, it's this distance. So I'll draw it in green. So it's going kind of like from here to here. And so you have to find that using like the Pythagorean theorem. So its coordinates are 0.25, 0.25. So the R is found by Pythagorean theorem, which I'll write out. And so, yeah, so you want to do negative K, which is not basically 9 10 to the 9. It's a constant in the book. So then if you do your 9 times 10 to the 9, and then your Q1, I think I'll run out of room if I actually write out what Q1 and Q2 are. So I'll just write it as Q1, Q2, and write Q1, I think is, let me look at the problem again. So 2.4 and 4.3. So 2.4 times 10 to the minus 6 coulombs. So micro is 10 to the minus 6. And Q2 is 4.3 times 10 to the minus 6 coulombs. And are those the numbers I actually used in the calculation? I'm just gonna like double check. Indeed, I did use those numbers. Okay. So yeah, so you want to write out Q1 and Q2, and then you just want to have, and keep in mind the signs. I think Q2 is actually negative. So then this whole prefactor should end up positive with that negative. Okay, and then I factored out this KQQ because it's common to both. The only thing that changes is R. So then you have R final, so it's final minus initial, is that distance of 0.25 squared plus 0.25 squared. If it hadn't moved on the x-axis, it would be 0.25 squared plus 0.15 squared. But since it also moves on the x-axis to 0.25, you have to use 0.25 right there. And then, not plus, minus the initial potential, which is the same prefactor with like that. And so if you put that in your calculator, maybe you'll get what I got when I put that on my Mathematica sheet, which is 0.36, negative 0.36 joules.